7 meters per second.
We're getting somewhere.
Yeah, all you have to do is just make up numbers then. So this now becomes 40 is equal to 7t. So we now can figure out how much time it's in the air.
Or you can, 5.7.
7, 1, 4, 2, 8, 3. And then repeating.
Yeah. Wait, hold on. 7, 1, 4, 2, 8, 5.
5.
7, 1,
And then
4.
that repeats. All right, so we now know how much time it's in the air. These become much more solvable. Ultimately, we're trying to find the height. Well, we have an equation right here. We don't know A. Oh, we can find the height straight from this equation right here. We've already done the hard work. And so H is equal to 4.435 times 5.714285 repeating seconds. And that is meters per second. So we're around 28.
I got 25.
You have 25?
0.3, 4, 2, 8, 5, 3, 9, 7, 5.
Units?
Meters.
All right. Now, I'm hoping that you see that had I supplied that one piece of information that I left off, that how to go about solving it, because I'm about to make it more difficult.
And so we were able to use time from the I hat
Right.
to work with the J hat.
Time is the one thing that combines the two. Time is the same for both. That's the only thing that's guaranteed the same for both. Because the ball is in the air horizontally just as long as it's in the air vertically.
What if it wasn't?
Then we have broken physics. I've tried to think of, in quantum physics, there are a lot of rules that suddenly become, things behave differently when you get down to that level. And I've tried to think even in quantum physics, I'm not quite sure how it could be in the air for a different amount of times horizontally and vertically. It's not to say some theorist hasn't come up with a way of doing it, but my mind can't grasp that happening.
Chuck the ball in the atomic bomb and see what happens.
I still would claim that it's in the air vertically as long as the same amount of time as it is horizontally. All right, let's make it more difficult. Because the horizontal throwing problem is boring if it's solvable. So let's keep it on Venus since we have that acceleration due to gravity. Let's start out with more traditional. Let's make this 20 meters. And this is what we're trying to find. This time, it's projected upwards at 30 meters per second and an angle of 37 degrees. The question is, how far from the bottom of the cliff is it going to land?
And we're still using.
Oh, there. Sorry. There's an eraser over there that I suspect I don't have to keep holding together. let's,
Do we keep the same definition that, you know, up is negative, down is positive?
I'm good with that. Did you wanna change it?
No.
So the question is where it would land on the ground.
Yeah, that's what we're trying to find. Assuming it's being projected from the edge of the cliff. All right, so first off, without just looking at the problem, what do we know?
This is gonna be heady. So,
All right, wait,
30 meters. 30 meters.
oh, I misheard. I thought you said acceleration.
Yeah. Is that the acceleration, 30 meters?
No, that's the speed, that combination with that is the velocity. What is the acceleration?
Is it the 8.87 meters per second? Since you're still on Venus? Or
I missed a word, I think. You said 8.87,
meters per second squared?
okay. Yes, which way? I've had two different hand gestures that contradict each other. It's accelerating upwards,
No, it's coming down.
I assume.
Yeah. So that would be,
I think it would be I hat, because we're going like,
no, it's J hat.
In which direction, if I took that ball and I just let go, what would happen to it?
it goes on down.
Yeah.
The time period.
I hope not. So, because it would just fall, we've got this acceleration downwards, and that's gonna be true, even if I project it out like that, we're talking about the problem, once it's in the air, not while it's being launched, but once it is launched, before it actually touches the ground, the acceleration is downwards.
So it's J hat.
So it is indeed J hat, so 8.8 meters per second squared. And what about horizontally? What's the acceleration?
0 meters per second squared.
no,
That's supposed to be a 2 there. All right,
Do we know the displacement for vertical, 40 meters,
yes,
and horizontal is unknown?
right, that's R.
Meters.
R. All right, so that's the fact that it's on Venus, we got our accelerations, the fact that it's a 40-meter tall cliff, it's gonna end up 40 meters below where it started, because that's part of the problem. And we're trying to find R, that's part of the problem. The velocity, though, we need to somehow take into account the fact that that 30 meters per second is not horizontal, it's not vertical, it is at an angle. And for those of you who were thinking you haven't been drinking a while, you're in luck. Of that 30 meters per second, we have to figure out how much is horizontal, how much is vertical. So I got 30 meters per second, or let's go ahead. That's 30 meters per second. An angle of 37 degrees. And part of it is horizontal and part of it is vertical. It is a right triangle because I hat and J hat are perpendicular, so we break it up into perpendicular components. How do we find the adjacent side here?
30 cosine 37 degrees,
Yep. And the opposite side to that angle?
30 sine 37 degrees.
Oh, sine. I thought you said times, so I was waiting for something else.
Alright then. Let's do the thing.
So not a button you're pushing. Anyone?
Okay, 30 sine 37 is 18.05.
Some 37 is 23.969.
Alright. Now, on this one, I would have been fine if we just gone with 18 and 24, but we can take it out more. Alright, so because it's connected to something more explicitly that we've done before, so my initial velocity in polar form is 30 meters per second, 37 degrees. That's polar form. What we're basically doing is putting it into rectangular form, given the way we've defined I hat, J hat over there. This is equal to 23.969 meters per second I hat. Finish it up for me. We're missing some stuff. No degrees.
Meters per second.
Okay, it is meters per second. Which somebody might have been saying, but very quietly. We're still missing something. A very critical piece here.
Plus sign.
Are we adding it? What's the J hat direction? What is positive J hat?
Down. So negative. I mean, plus negative. Oh, yes, negative. Why is it negative?
Because it's going up. Initially, this is the initial velocity. Initially, it's going upwards, and we said down was positive.
So this means up is negative.
The critical thing, well, actually, we'll go ahead and stick this in over there, and then I'll talk about if we had chosen up to be positive. So this was 23.969. And this is 18.05. Negative. If you had kept this as positive, that would be as if you were throwing it that way. You'd get a much smaller range here.
I see.
The critical thing in this, because it's being thrown upwards, the displacement is down, this is up, this needs to be a different sign than these two. These two need to be the same sign in this problem, that needs to be the opposite sign. So if we had chosen up to be positive, that would be negative, that would be negative, that would be positive.
So the displacement and the acceleration have to be the same sign, and the initial velocity has to be the opposite sign of the displacement and the acceleration.
I hesitate to make it more generalized. If I'm throwing it up like that, then yes.
Okay.
If I'm throwing it up like that and it lands below. But I have had problems where I throw it up and it lands at a higher level, in which case initial velocity, vertical velocity, and displacement are the same sign.
On a circumstantial basis, this is what we come.
So we are now left with this. Questions up to here before we get into algebra.
Oh, we just sit straight, we're fine.
So let's do some algebra. All right, so what do we need to, so we're trying to find for R, but we can't solve for R yet. We need to have one other piece horizontally, because I really only know two things here. Now you can make an argument, we do know a third thing here, which sort of contradicts what I said before. Because these are not independent of, well, badly worded. Because acceleration is zero, these will end up being the same, whatever the value is. That's knowing three things, that's not gonna really help us find the other two. So what do we need, for what do we need to solve?
Time.
All right, we're gonna use the vertical aspects, we're gonna use this to find time.
Yes.
So what equation do we use?
The change of position, no. Yeah, change of position equal, no, never mind. Oh, final velocity equals initial velocity plus acceleration, time.
What's wrong with that?
Well, we don't know the final velocity
Or time?
or time.
It'd be helpful if there was an equation, if we're trying to find time, is there an equation where we have, where we don't need to find the final velocity? So is there an equation which doesn't have final velocity in it?
Second one.
Yep. So I got 40 is, let's go ahead. Equals VIT plus 1/2, that's an I, AT squared. We are only plugging in the J hat pieces to this. We're not plugging in the I hat or that 30 meters per second. If you get to a problem like this, and you put in 40 meters, because that's the vertical displacement. If you put in an initial velocity of 30 meters per second, I generally stop grading at that point and just put a giant X on it. Because the 30 meters per second is not in the J hat direction. Part of it is not, so that does not go here. So what goes here is the negative 18 plus 1/2, 8.87 G squared.
And that's because, and it's like that because it's at an angle. Had it been directly shot that way, then we would just run with I hat.
Yeah, this would be 0 in that case.
Right. I mean, like, if we had the I hat.
All right. I now have a quadratic equation. How do I solve it?
We can first set it equal to 0, quadratic formula, crap out.
All right, so I've got 0 equals 4.435 t squared minus 18.05 t minus 40. Now what?
Quadratic formula,
Yes. There, negative t equals
18.05 plus or minus square root of, negative 18.05 squared. Minus 4 times 4.435 times negative 40, over 2 times 4.435.
Now, before we actually get an answer, we should recognize there's gonna be two answers. Will they both be positive, one negative, or both negative?
one be positive, one be negative.
Okay, which one will have a greater absolute value?
The greater absolute value.
Positive?
Yes.
Huh?
Because the math problem that's being solved here, when time is 0, it's going up. The math problem that's solved, trying to find these values right here. The negative value is much closer to 0 than the positive value. If it were being thrown downwards, then the negative would have the greater absolute value. All right, so what are the two answers?
So, for the plus, I got 4.204. And for the minus, I got negative 0.134.
Negative 0.134.
Yeah. Gotta do something wrong.
Yeah, something doesn't sound right there. Anyone else got these same numbers?
I got 5.66 seconds. And then negative 1.59.
Alright, that makes more sense. Anyone get these numbers? We have a third set?
So, for the negative, I got negative, 0.1737. And then for the positive, I got 4.243. Or if you round up, that would be 4.
I'm still liking this one the best. Which one did you get?
I got the